Hi everyone. In this lecture, we are going to learn how to write a recursive function to compute nth Fibonacci number. Okay. So if you have not heard about Fibonacci series, I will tell you it is a very simple mathematical series in which the first two terms are 0 and 1, and every term, every ith term is the sum of previous two terms. Okay. So I can say the nth term is nothing but it is sum of previous two terms. Okay, f of n minus 1 plus f of n minus 2. And if I talk about what would be the next term, it would be sum of these two, that is 1. What would be the next term? Sum of these two, that is 2. The next term would be 3. The next would be 5. The next would be 8. The next would be 13, and so on. Okay. So what we are given a particular value of n, and we want to tell, okay, what is the nth term of this particular series. Okay. So for example, 0, 1, 2, 3, 4, 5, 6, 7. The seventh term of this series is going to be 13. The 11th term is going to be some xyz. The fifth term is nothing but 5. So we need to figure it out. Okay. So as I said, when we are dealing with recursion, we will need two things. One is a recursive case that we've already seen. We already know about this problem. And second is the base case. Okay. So the idea of picking this problem is not to teach you the code, because code is very simple. The idea is to teach you the concept of recursion when there is more than one call. In the previous question, we saw there is only one call happening from each function call. But in this case, from each function call, two calls are going to happen. Okay. So we will talk about how the recursion tree would look like in this case, and what would happen to the call stack and so on. Let's also talk a little bit about the base case. So base case is going to be two cases. Let's say you're computing for n equal to 2. So 2 is going to make two calls, one on 1 and one on 0. But now at 1, what you are going to do? Will you make two more calls? Will you make a call on 0 and minus 1? The answer is no. We cannot make calls on the negative indices. So that means we have to take 1 as a base case and we have to take 0 as a base case. So this part is not needed. So we will have two base cases here. The value of n equal to 0 is going to be 0, and the value of n equal to 1 is going to be 1. So let me first show you the code, and then along with the code we will try to dry run how this code is going to work. Okay. So let's make a new program for Fibonacci, and let's copy little bit from here. So this is now fib, and this is now fib. So as I said, we are going to have two base cases. Okay, so I can put both of them in a single condition. If n is 0 or n is 1, we can return n. That means if n is 0, we are returning 0. If n is 1, we are returning 1 actually. Otherwise, we are going to say we are going to compute two values. One is f1, that is fib of n minus 1. Another value is f2, that is fib of n minus 2. And our answer would be nothing but f1 plus f2. Okay. So we could have directly written return fib of n minus 1 plus fib of n minus 2. But just to make things easier for you, for the first time, I have written the code like this. Okay. Now this will also make the understanding of call stack more clear. What is exactly happening? So now this is the code. Let us first run it, and so dot slash Fibonacci. If I say, okay, tell me the seventh term, it is 13. Tell me the fifth term, it is 5. That means it is working perfectly fine. Now let us see what happens at the call stack level. So let's say this is our call stack, and I'm going to run it for a small example. Let's say for f n equal to 4. Okay. And now in the beginning we had only main. So what happened is from main we made a call to f of Fibonacci of n equal to 4. So we called Fibonacci with the value of n equal to 4, and it tried to compute the value of f1. So it made a call to 3. So it called fib of n equal to 3. Okay. And at 3, what it did, base case is not true. It tried to make a call. So another call it will make, but it will make later on. that is to n equal to 2. So these calls are not executed yet. These will be executed later. So 3 made a call to 2. So 3 made a call to 2. Okay. And what happened at 2? 2 must have made a call to 1. Okay. So fib of 2, it made a call to f of n equal to 1. Now at n equal to 1, we saw that this function hits the base case and it will not execute this code. It will return a value of n, that is 1. So 1 actually returned 1. So this actually got removed from the memory. Okay. So this actually got removed from the memory. And now what happened is, so this branch is also gone. Okay. So this branch returned 1 and it is now gone from the call stack. Okay. So what is going to happen is 2 computed the value of f1. 2 is now going to compute the value of f2. This function will now execute line number 10 for the first time at this particular point. So it will make a call on 0 and 0 will return a value of 0. So it will make a call on fib with n equal to 0 and this is going to return 0 and this is again going to get popped off. This is going to get removed from the call stack. So at this point, this is how the call stack is going to look like, and 2 knows my answer is 1 plus 0, that is 1. 2 is going to tell 3 that my answer is 1. So 3 now only knows one of the answers. Okay, so 3 knows the answer of f1 for 3 is 1 and 3 is now going to compute f2 for which it is going to make another call. So this is going to get removed. This is going to get removed. And what is it going to do? 3 is going to make a call on fib of 1. Okay, so it is going to make fib of 1. So fib of 1 will get added in the call stack and it will again return 1 to 3. So it will return my answer is also 1. Okay, so at 3 what it is going to do? Now 3 knows that I know one answer was 1, the another answer was also 1, so it is going to return 1 plus 1, that is 2. And now 4 knows that my f1 is 2. So 4 gets to know that one of the answer is 2. Okay. And now 4 is going to make a call for f2, that is this line number 10, and this call will get executed. Okay. So we make a call at 2. So same story is going to repeat. 2 is going to make a call on 1. 1 is going to tell my answer is 1. It will get added to the call stack. Then once it returns, it will get removed. Then 2 will make a call to 0. 0 will return again 0. And 1 plus 0 is going to be 1. And at 4, we earlier knew that one answer was 2. And f2 is now 1. So it is going to return 2 plus 1, that is 3 to the main. So fib of 4 is going to be 3. So I've not drawn the call stack completely, but what I am trying to tell you is, if you want to make it easy, if you want to see how many calls are made or what calls are made, so the ideal way is to draw it using a recursion tree. Okay, and from this you can easily estimate the space time complexity of the program as well. So what happens at n equal to 4, or let us do it for n equal to 5. So 5 will make 2 calls, 4 and 3. This call will happen later on. 4 will make 2 calls, 3 and 2. This call will happen later on. It will make 2 calls, 2 and 1. This call will happen later on. It will make 2 calls, 1 and 0. So 1 will execute first. So 1 will return 1, 0 will return 0, 2 will return 1 and 1 will return 1, 3 will return 2, 1 plus 1. And 2, now 2 is not going to return anything directly because it is not the base case. So we need to further expand it. So 2 will make 2 calls. It is going to return 1. It is going to return 0. It is going to return 2 plus 1 plus 0, that is 1. And 4 is going to return 2 plus 1, that is 3. And now 5 is going to make a call on 3. 3 is not a base case. It's going to call on 2 and 1. It's going to call on 1 and 0. It will return 1, it will return 0, it will return 1, it will return 1, it will return 2, and 5 is going to return 3 plus 2, that is 5. Okay, now these are the number of calls that we have made, and roughly the number of calls in this case, if I talk about on the first level I have 1 call, on the second level I have 2 calls, on the next level I have 4 calls. So it is a GP and we have roughly n levels. So approximately we are making exponential number of calls. The time taken would be the number of calls plus time in each call. So in each call we are doing a constant work, that is adding two numbers. So it is order of 2 raised to the power n. Now what about the space? How much memory we have taken? So in the worst case, the maximum depth of the call stack would be this much. Okay, because at any point only one of the branch is going to exist in the call stack. Okay, so the memory of the program would look something like this. It is increasing, then maybe decreasing, then increasing, decreasing, increasing, decreasing, and finally 0. Okay. So in this particular branch the utilization is maximum. Okay, so it would be something like of this kind. This is when n equal to 1 was hit, this point, and this was n equal to 0 was hit, something like this. At these 2 points the space utilization is maximum, so the time is order of 2 raised to the power n, the space utilization is order of n. This is how the Fibonacci is going to work. I hope the concepts are clear. That's all for this lecture. Thank you.